I think this section is kind of cool, and maybe you will too. Properties of integrals. Yeah, you could read through this, but the coolest one that I think happens to be this one. So to get from A to B, you might go from A to C and then C to B. The cool thing about that is you can even go backwards. All right, let's say we have these numbers. Okay, if you wanted to get from 1 to 8, you could go from 1 to -2 and then -2 all the way to 8. Right? I mean, why, right? Why would you do that? Maybe you want to get your extra steps in, but just know that you can do that. Some of those other properties we've already discussed, and some things you'll figure out. Like this one's kind of cool if you graph it visually. All right, but let's talk about properties here. We want to go, we know 0 to 10, that's 17. We know 0 to 8 is 12. Now intuitively, we should be able to pick something else out. I'm going to show you mathematically what I'm saying. So 0 to 8, and then 8 to 10 would be equal to 0 to 10. Now, I know you might not want to write all this out, but just do it. Okay, 12 plus this integral expression here is going to be equal to 17. So that means this expression is equal to 5. Okay, and that should make sense. If 0 to 8 is 12 and 0 to 10 is 17, you gotta have 5 in there, right? So that's going to be the key to being able to solve something more complex like this one. All right, so we just said 8 to 10 of f of x is 5. Okay. So I'm going to explain some of the properties here. That 3 on the inside, we can just pull it right out. And because we have two terms being added, we can also break them up into two integral expressions. So like I said, I'm going to pull that constant rate out of there, get it out of the way. And since I have two integrals that are being added, I can also break them up. So we already know this first one, so that'll be 3 times 5. But what is the second one? Let's think back a minute. What does the graph of 2 look like? That would just be this. And we need the area here from 8 to 10. So that's just a rectangle. Okay, it's 2 high and 2 wide. So that is 4. Okay, 2 wide and 2 high. So we have 15 plus 4. That would just be equal, that big old expression, 19. All right, now let's look at this. We have 4 to -6, 3 to 7, 4 to 7, and we got to figure out something. So let's break this down. What are we even trying to figure out? Let me get another color. Break that one down. That's divided by 2. Bring it to the front. I need to go -6 to 3 f of x dx. And I'm also going to have to do -3, -6 to 3, 3 dx. All right, well, I know this piece. That's a rectangle, right? How big is that? Well, I guess I should not have that 3 in the front. All right. So it's 3 tall, and it's from -6 to 3, so 9 high. That would be this piece. So really, we just need this. What do we already have? All right, I need -6 to 3, so how am I going to get there? Well, it looks like this. If I go -6 to 4, and then 4 to 7, and then 7 to 3, that's going to be equal to the same thing as -6 to 3, which is what I need to figure out. All right, I don't have -6 to 4, but I do have 4 to -6. That's -3. So if I'm going the opposite direction, I take the opposite sign. Okay, I have 4 to 7. That's 5. And I don't have 7 to 3, but I do have 3 to 7. So I just take the opposite sign. So that's going to be equal to -6 to 3 of f of x dx. So what's that? Negative 1? All right, now let's use that and finish the problem. This integral part is negative 1. So we have negative 1/2 plus 27 as our final answer. All right, finally, last page of notes. All right, we have some facts. I think I made it, there might be a printing mistake, maybe not in yours, but there is in mine. Anywhere that you don't see something, I think it's pi. I think there should be pi's here. If not, sorry. Pi's all around. So I think plus 2 pi, or pi plus 2. I don't know. Maybe I'll let you do that one since I don't know what it says. 2 pi, negative pi to pi. 0 pi, 2 pi. No, it might be 2 to pi plus 2. Sure, we'll go with that. All right, so either way, what we figured out, the area here, that didn't help to draw it in that color. This area is 2. Using the symmetry of sine, we can figure out that that area is also 2. Okay, so if we continued this graph from pi to 2 pi, we would see that this would also be 2. And we can kind of continue that pattern on. I didn't draw it very accurately, but that's okay. So if I go from pi to 2 pi, that's going to be negative 2 because we're below the x-axis. If I go from 0 to pi, I have this positive piece and this negative piece, which cancel out, so that's 0. All right, this one, it looks like I'm going from pi to 1/2 pi. So I'm going backwards. So it looks like that would be negative 1. Okay, this one, I'm adding 2 to sine. So I'm just taking that graph, I'm going to add 2 right under it. Add 2, there we go, this way. So how wide is this? That's pi, right? So now my area is going to be 2 plus 2 pi. Okay, this time if I throw a 2, there's a lot of 2's in this problem, right? All right, so I don't have too many colors available. Let's change that blue. All right, 0 to pi of 2 sine of x, so that's going to be 2 times as tall. Normal sine only goes up to 1. This one's going up to 2. So how does that change the area? Well, it doubles it. Or you could think about it like this. 2 times this. So 2 times 2? 4. All right, what does this do to our function? This is kind of a review of functions too. Well, it moves it to the right 2 units. Well, 0 is also moved to the right 2 units, and so is this. So our area is still 2. Okay, this one, sine of x over 2. Well, that changes our period. So that makes the period 4 pi. So what this does is it kind of stretches out our function. Okay, stretches it out way more. And we're only going 0 to 2 pi, so we want this big piece. Okay, so that is also going to double our area. Ooh, this one, that's for you. Cosine, oh, that's different, right? What does cosine look like? I'm sure you remember, but in case you don't, cosine starts at the high point. So 0 to pi of cosine, there's a piece, looks like that's a big fat 0. 0 to 2 pi, so we have some stuff above, we have some stuff below, so 0, and what a good note to end on.